Okay, and welcome to week 6. Time is going by fast. I had a couple questions related to the project due at the last day of the month, which is, I think, next week. What do you think about that? Again, I'm not really worried about what reference style you use. Please do use references if you cite something like a news article, if you say something factual. Um, I don't really care how long it is. Generally, it's between 8 pages. Some people put a lot of graphics in it. It gets 8 or 10 pages. Some people have sample data, 8 or 10 pages. If you're just kind of exploring ideas, maybe 3 pages. It Don't focus on the details of that. What's important for me is that you have kind of an idea. When I'm going to show you the assignment, that you have an idea and why that idea is a problem or why that idea important. Okay, and I know that sounds crazy, but you know, when people ask me about my job, all I can really say is, hey, I'll pick up a project, I'll do something if it can reduce money for the company and it makes patients happy. I won't do one or the other. It has to do both. You have to have some type of idea of why this is a problem. So a problem isn't, airlines are late. That's not really a problem. Who cares if airlines are late? Well, airlines are late causing customers to use other airlines. That is a problem. Remember your SMART goals. So if you tell me that something's a problem, you have to explain why it's a problem. Car theft is a problem. What do I care? Car insurance. Uninsured motorists are a problem. Why do I care? I have insurance. Uninsured motorists are a problem in Nevada, and it causes insurance rates to go higher for everyone, and uninsured motorists are more likely to get in an accident. So there's why uninsured motorists are a problem. So make sure when you define a problem, you tell me why it's a problem. Number two, how is this going to help generate new business? Or I don't want to say new business, how is this going to impact the world? So since uninsured motorists are a problem because they get in more accidents and they lead to higher costs for everyone, if a company can find a way to reduce uninsured motorists, they will make more money. Their customers will be inherently safer, and their customers will save money. That's a win-win for everyone. I mean, if we all had car insurance, insurance in theory would be cheaper for everyone. That's a win for everyone, including the insurance company, including us. Okay? So why is this topic? What is it going to impact? You have a problem, and why it's a problem. What is it going to impact? Then the data. Now this is going to be kind of more of a nebulous thing. If you find data, maybe you can't, maybe you can. Just explain if you could. If the sky was the limit, what would you do? Hey, I'm going to get every mile that uninsured motorists drive versus every mile that insured motorists drive and create an average insurance mile, thing, blah, blah, blah. And that's probably not really practical because we only have estimations of how many people are uninsured. But, hey, if that's what you want to do, that's fine. I don't have a problem with that. This is not about being, I don't want to say factual. It's not about, finding the data. This is about, hey, if you could find the data, how would you do it? What type of data would you expect? What type of data would you need to get to solving your problem? That's a really, really big issue. A lot of times we can define a problem, why it's a problem, and we know how it's going to help the business, but we don't have any idea what type of data can help solve that problem. It's probably one of the biggest problems when dealing with people outside of our field of intelligence and big data. What type of data do we need to fix this problem? Then once you get that, that's going to be the bulk of the work. That's going to be, let's say if it's 10 pages, that's going to be 8 pages, okay? The last page is how do you share that data? How do you transfer that data? How do you give back that data or that knowledge to the world? Hey, uninsured motorists are a problem because it makes everyone that drives at risk, high risk. My research idea is, hey, I'm going to track every uninsured motorist and see if there's a certain time they drive or a certain location, blah, blah, blah. Okay, and here's, so in theory, I'd need like satellite imaging and targeting of every uninsured motorist. That would be so cool. And then we'd stoplight cameras of every uninsured motorist that doesn't have a license plate. We get all this data, and then we can say, hey, these people are driving with no insurance. Let's go to their house and talk to them, blah, blah, blah. So you have all that. Now, you have to sell that idea. You have to tell people about it. So, hey, what I plan to do is I plan to inform the police of, hey, here's 10 ways that the police can reduce uninsured motorists. I plan to have seminars at insurance companies on how to target uninsured motorists. I plan to have a website that says, hey, here's how we can do this. Because a big part of data science is not keeping the data to yourself. A big part of it is expressing, communicating, sharing that data. It doesn't have to be something crazy. Hey, I plan to put it on GitHub and make it open to the public. That works. I want you to start thinking about, hey, you found a problem. You figured out how to solve the problem. You got data in theory how to solve that problem. And here's how we're going to share that problem. Okay? So that's really the research idea. Don't freak out over it. You can send me drafts. Just give me maybe 5 days. So let's say maybe by the end of this week, whenever the last day of the month is, take 3 or 4 days off. And as long as you have some type of proposal or some type of idea to me that I can read, like let's say a week in advance, I'll read it and give you feedback. That's totally fine. A lot of students do that. They send me a draft of their ideas, and they're like, hey, what do you think of this? I read it, and I can either mark it up with like an Apple Pencil and make comments. I can do a video, whatever works. I want to see you succeed. This is a very easy, but yet very important topic. I was just talking to a student the other day, and they're using this, and they're going to take it as part of, they're kind of exploring different ideas to do their keystone or capstone project in. Okay? So this is very important. If you do a PhD, this is what your whole PhD is going to be on. I mean, this type of thing is what a lot of people kind of expect. If you go into business and you have to present ideas, this is all what it is right here. So please take this very seriously, and again, do your best. I'm here to help. If you have ideas, questions, you want to send me a draft, just make sure I get it a week before. So you guys are doing fine. So now let's dig into the kind of last 2 chapters we hit. Next week I might do like a recap of this book, just so you have an idea. I'm still trying to figure out how to wrap this book up. Again, these 2 chapters were pretty heavy, but there's some key concepts in here that I really want you to understand, at least visualize in them. Okay. Summarization and semantics. I already covered this. I don't know why I have that in there. So now, how do we summarize data, and why is it important? I don't think the book goes into enough detail as why summarization is so important. And 5 years ago, it wasn't nearly as important as it is now. Today, we're in a world where businesses and students and people, we have to do more in less time. Okay? It's not like we're producing less peer-reviewed journals. It's not like we're producing less books. We have more access to information than ever, but we have less time to critically analyze and critically think about that. So we have to find ways to work more efficient. Text summarization is a crucial point of this, is a crucial part of this. I've talked very briefly about my master's. One part about my master's was I used NLP. I used text summarization to take clinical trials and summarize it. Is this what we're looking for? Yes or no? When we're unsure, we can dig in a little bit more. But is this what we want? Yes or no? One of the reasons for that is because if you're doing clinical trials, you're doing any type of research, 90% of them all start out the same way. In Parkinson's, for example, Parkinson's is the second most common neurodegenerative disease. It affects 1 million people, and it just goes on. And to have to read that 3,000 times, I would kill myself. It would be horrible. Alzheimer's is the #1 neurodegenerative disease. It's an accumulation of plaques in the brain. Blah, blah. Dude, tell me what the story is. Tell me what you're publishing. Give me 1 sentence about what you're publishing. Give me 1 paragraph about what you're publishing. I don't care about every article says that. I need to know the guts of what it is. Once I get the guts of it, then I can figure out, do I want to keep it or do I want to get rid of it? And that one, I guess, fact that I put in my master's degree, it was almost an afterthought because I was just curious. I got tired of reading all this stuff. Made a huge impact. So text summarization, I cannot stress how important it is. We're in a world where we have information overload. In my field, we have physician burnout. Okay, there's a lot going on right now in the medical world where you have a patient and they're seen by 10 doctors, and all 10 doctors write clinical notes, and then 11th doctor comes on. What's he going to do? Read all 10 doctors, 10-page notes? That's not practical. How do we summarize what all 10 doctors said to one page? There's whole divisions right now at United Health Group and Optum and Aetna and Kaiser Permanente to figure out how to make a one-page cover sheet that talks about this patient. It's a huge problem. How do we summarize thousands of pages down to one that's relevant? One thing that I've been studying in the last, year or so is how do CEOs impact the stock prices? We don't care about CEOs from 20 years ago, or do we? How do we summarize down to what's just accurate now? We can save time and efficiency and VCV productivity. We can enhance the accessibility of information. Some things are very complex reads. This book and the Transformer books can be kind of hard to read. But if I can summarize it, like what I do, what I try to teach as, try to make it easier for you to understand, you can take that information as a foundation and grow on it. But if you have this really complex foundation, it's just spaghetti wrapped and you just don't know what way to go. Support for multiple languages, that's vital. Gone are the days where something that's in Russian, it's inaccessible to people that don't speak Russian. Gone are the days where something that's in Chinese that's not accessible to Americans, and vice versa. If you're in Japan right now and you don't speak English, you see an article or something you want to read, you can translate that instantly. Google does it on the fly. Not only can you translate, you can summarize it. It's so important. We integrate with other technologies. I saw a video just the other day where they had some type of headset hooked up to a person, and you could ask a question, and it kind of summarizes that question, Googles it, and comes back and gives you the information. Search engines, they summarize data. Voice assistants. I don't want to say, hey Siri, but hey Siri, do X, Y, and Z, and we'll kind of summarize that into actions I want. So text summarization is so important. Now, there's two different types of text summarization. I'm going to go into another one, but I just wanted to dig in and really kind of hit this first. What we do is we take a corpus of text, 10,000 words, 300 words, doesn't matter, and we convert that to each document. Generally, that's a sentence or a paragraph. But then we create, remember that IDF we talked about? We create a term matrix. What terms are important in that sentence? We call it a document, but what terms are important in that document? Okay. The TDM contains a frequency of those terms that appear in that document. And remember, document can be a sentence. It's just I know it kind of is confusing, but that's the correct term. Once we have a list of rows of term documents, once we have a matrix of all this information, a table, okay, we can use something very similar to PCA. Again, we talk about PCA. Hopefully you guys understand what PCA is. Principal Component Analysis. I just forgot what PCA is. Principal Component Analysis. There we go. Or T-sign or any other method that we do, dimensional reduction. And we try to figure out what makes that sentence tick. What makes that sentence valuable in context of other sentences. Okay? If I was to give you a data set, let me switch over my iPad here real quick, do a real quick demo. And this is only the quickest one I can think of, but we want to look at house prices. And we have the number of rooms, number of garage doors or garage ports, whatever you want to call it, number of windows, maybe the direction it faces, the front door, whatever, if it has grass in the front, and there's all types of crazy demographics, you'd be surprised. Grass or rock. Let's see what else. And, we keep adding these variables on here. I mean, you just keep adding them on and on. Well, I look at a house at 300,000, and I get all these variables. I look at a house that's 300, 400,000. We got all these variables. House is 500,000. I don't know why I'm picking round numbers. House at 325. We got all these. Well, if I get too many data sets or too many columns, let's see, too many dimensions, it's going to slow down my analysis, especially as my data grows and grows. And now what I can do is mathematically say, hey, these two are related at, let's say, 80%. So I know that 80% of the price of the house has something to do with rooms. Now, the garage door might only be 10%. I'll make sure I know it's a really ugly drawing already. 10%. The number of windows, maybe I should start changing colors. The number of windows might only be 1%. 1%. The direction it faces might be 3%. I guess I should pick a different color. Okay. Grass or rock might be 0.5%. So on. So I know that if I have the number of rooms, okay, the number of garage doors, and maybe the direction the house faces, direction, I can get within, I don't know, let's say 93%, 93% accuracy, okay? And I can not have to process this, and not have to process this, and this, okay? That's kind of what PCA does. That's dimensional reduction in a 10,000 foot overview. Okay. If you guys want, I think I have a lecture somewhere on PCA or T-sign. So, again, we take each document, each sentence, each paragraph, and we figure out what terms are valuable in it and the frequency that they appear. Then we use a singular value decomposition, a mathematical model. It identifies patterns in the relationship between the terms and the document, basically the frequency, and kind of reduces the dimensions of the document to make it easier to process. We do the dimensional reduction because we know, because of singular value decomposition, we know what's important and what's not important. Well, if we know something that's not important, we can throw it out, clean it up. Dimensional reduction. Then we can rebuild a sentence, or we can rebuild a document based on the reduced dimensions of the data. Very complex, but really not that hard. Okay, this is one of the two methods. I wanted to introduce you to this one first because it's kind of the harder one, kind of the clearer one too. It tends to be a little simpler, but if you can't understand this, hey, we have a whole bunch of documents. We look for the words, kind of like an idea. We look at the frequency of the words. We kind of figure out what words are valuable and what words are related to other words. If you see the word Richard and lawsuit, even if they're maybe not in the same sentence, but they're really close to each other, somehow those words are related. But you see the word court, maybe those words aren't related. Maybe they have no value. You dimensionally reduce them, you get rid of them, and kind of rebuild that document. Okay? So that's one method. That's an extractive summarization method. I kind of wanted to tackle that one first. That is not how ChatGPT and a lot of other methods do summarization. Okay? That is an important method. Some specialized models do that, and some specialized software doesn't. But that method the extractive summarization method. It involves selecting and extracting phrases or sentences or segments from the source document to form a summary. The goal is to identify the most important parts of the original text and combine them to present the gist of the context. Okay, so now, let's think about this. Why do we want to use that? Well, hell, medical records, legal paperwork. I mean, we don't want to summarize legal doctrines. We don't want to summarize legal precedents and laws. We want exactly what the judge said. We want exactly what the fine is. We want those exact terms. Same thing in medical. We don't want to summarize, he kind of had cancer, he maybe kind of had kidney disease, and we're summarizing. No, you want the exact terms. You want to figure out, in the last 100 pages, what is the most important things, and almost verbatimly copy the most important things to the cover sheet. That's extractive summarization. Kind of more rare, but super valuable. Abstractive summarization. We'll deal with this more in the Hugging Face things, but we're using machine learning models to try to get the understanding of it, the flow of it. What do they mean by this? And what we get from what they mean by this, then we can kind of abstract, say, hey, this is what they meant. This is what we think they meant. Okay. Your book does talk about this in a little bit more detail, but to me, these are what you need to understand. These are two major types of summarization that a lot of people don't talk about. They have very distinct, very different uses. When I'm grading your homework, what one do you want me to use? Give you an approximate grade? Do you want me to give you an exact grade? If I had to do surgery, do you want me to give you an approximate location where I had to do a surgery at, or give you an exact location? If you're reading, if you throw this book, whatever it is, the book, into, I don't know, ChatGPT or Claudia, and you say, hey, can you give me a summary of chapter 2, API? We didn't cover APIs. Can you give me a summary of chapter 2? You want an abstractive summary. You want, chapter 2 talks about A, B, and C, and this is kind of what it talks about, and these are general points. That's where you want that type of creativity. The two very different types of summarization. Sorry, getting there. Okay. Accuracy of information is crucial. Selection-based, it works by scoring and ranking parts of the text or document on matrix like relevance and informations. Maybe I spelled that wrong. And then picking the highest ranked ones for summary. No rewriting. The extracted sentences are not modified, but are taken verbatim from the original text. Or they're maybe concatenated, but you're not adding new words. So that's why I put a Xerox copier there. Because you can take a Xerox copier, you can make things smaller, but you can't add new things to it. Okay. Simplicity. Generally, this is easier to implement and understand as it relies on straight math, pulling out significant text portions. If you read a 10-page document, and then on page 3, you see all capital, all bold, oh my God, this is going to happen. Warning, do not skip this part. You can kind of know that's important. Now, the limitations are that the summary may lack fluency or cohesion because sentences they're taken out of context. And when you put things back together, they may not always make sense. So just keep that in mind. That's abstract summary. See, that's like a shadow, abstract or something. It's generative based. It's an LLM based. We use these bidirectional encodings. We do a lot of different things. It's much more complex, and sometimes we don't always understand how it's getting these. It's not always explainable, but it can be personalized to me. It can be customized to me. I can go from one language to another language. Okay. So when you think about summarizing data. These are the two major issues that you want to at least have 100% down in your head before you move forward. Now, sentiment analysis, chapter, what was it, 11? Okay, I'll get you code demos of a lot of this stuff. The abstractive summarization we'll deal with in Hugging Face because, again, they have tons of great models for that. So, sentiment analysis, this is kind of a little bit harder to at least wrap our heads around. In the world of text, I guess in the world of data, you have categorical and let's just say non-categorical variables. Well, in text, you have subjective text, which are like facts. They're not always true. I didn't say they were true. I just said you had facts. And you have subjective text, emotional text. You have emotional words. Sentiment analysis is designed to work on the subjective text. I went to Taco Bell and I did not like the tacos this time. I bought a new Ford Durango or Dodge Durango truck and it was making funny noises. I'm very unhappy. Vegas is a great place to live and raise kids. Vegas has 3,200 people. The last one was objective. You know, it might not have that many people, but there's no room for interpretation. You know, it's A equals B. Sentiment analysis, we were trying to take those subjective values of subjective strings and try to assign either a positive or negative or emotions or understand them in a different way. A way that we can gain insight into the customer, gain insight into that corpus of text. Just like summarization, there's two main types. Over there, it was, I forgot already. It was extractive, where you extract it, and abstractive, where you kind of summarize. Here, there's rule-based. If you see this, do this. It's lexiconical. If you see the word happy, it's positive generally, or machine learning based. And guess what? We'll deal with the machine learning based in the Hugging Face part. Now, the types of sentiment analysis. So there's polarity detection. If you look on, I think that Amazon data set I sent you, or that you have access to, or one of the demos, it has a +1, 0, or -1. That just shows, hey, is it happy, neutral, or negative? Okay, it goes anywhere from 1 to 3, 1 to 2. It just depends on the data set. I mean, there's different ways to detect this. Some humans can encode it. Sometimes you can do like a score. You know, would you recommend this restaurant? Yes or no? And leave a review. Well, if they say yes and say, hey, this is a great restaurant, +1, there's your text. Negative, I will not recommend this restaurant. This restaurant, the food was cold. That's a negative review. So that's one way of doing it. There are a few other ways, but you know, you just get the idea. You can have some type of Likert scale and some type of text. Emotion detection. Now this gets a little hard, but we're trying to detect if a particular pattern of speech is happy or sad or emotional. I mean, what is the emotion bearing in that text? It becomes a little bit more complex, but it can be done. And an aspect analysis, okay, which, you know, is there, you know, if I give you 2 or 3 sentences, is there something particular you like about that? This car was a great value. That's an aspect of the review. That's an aspect of the sentiment. I went to this restaurant because it's quiet all the time and there's not a lot of other people around. That's an aspect, okay? Now, we're human, and you know, again, I have a hard time sometimes detecting sarcasm and irony. My wife doesn't. But if I have a hard time, machines have a really hard time detecting sarcasm. And you know, you look at this, and a lot of times people will use the word happy or great day. Oh boy, I got in a car accident. It was such a great day. How would a machine interpret that? And these can be big challenges Contextual meanings. Words can have different meanings. I don't know if it was this week or last week, I gave you that gardening example on TikTok, which is like smoking marijuana, weeds. Smoking weed, I just had to think about this, but smoking marijuana. So there is a contextual meaning of a word that has nothing to do with a dictionary term. Okay? Machines have a huge problem with those. Okay? Languages and dialects. A friend of mine is from the South, and he uses the term "shut your butts." It means be quiet. But shut your butts. That's a dialect. That's a language-specific term. Californians have language-specific terms. Nevadans have language. Texas, roll tide. These are dialect-specific terms that sentiment analysis can have problems with. They can rank them wrong. So, lexiconical based is just a list of words. There's one out there, I think, on the internet that has like 300,000 words, and it ranks the words as positive, negative, neutral. If you see the word kill, you can generally assume it's negative. If you see the word happy, you know that's positive. Joyful, happy. Firefly, probably neutral. Okay? You calculate the overall sentiment. So let's just do a real quick one of this. So if I was to look at the word, I love sunny days, but hate the rain. Well, if I assign the word love to +2, sunny +1, hate to -2, and rain is -1, the sentence, I love sunny days, but hate the rain, comes out to a 0. See, this is pretty easy stuff. There's data sets out on the internet. Basically, dictionary, tokenized, boom, boom, done. How accurate this is, that's a different story. But the actual process of this, you can understand. Supervised learning, completely different method. Okay, so a lot of times with supervised learning, text can be labeled either by a group of people or by different methods. And once we have some type of labeled text, either words or sentences, once we have enough of that labeled training, we can run it through a machine learning model. Once we run it through a machine learning model, we have to split between test and train. But once we do that, we say, hey, here's something it's never seen. I know it's positive. Does it think it's positive? Here's something it's never seen that's very negative. How does it rank it after the training? Because remember, machine learning will go through and try to update its weights on the training set. And then we're going to test on the test set. Model evaluation. There's different models to evaluate it, but you kind of get the idea. Typically, labeling involves multiple human annotators reviewing a piece of text and determining its sentiment. This process can be both time-consuming and costly. If you look at Amazon Turk, it's just Amazon, I think it's TURK. Amazon Turk people, humans, get paid to do things like this. So they might pay you a penny to look at a sentence and hit plus if you like it or minus if you don't. You know, Amazon Turk has all these weird little tasks to label data, projects, pictures, things like this. Okay? Machine learning with large enough data sets does very, very well with this. But it's getting that data set, getting that supervised data set that can be hard to generate. So again, another 30-minute lecture, so not super long. Please focus a little bit on your research, on your research proposal. Email me if you have questions. If you want me to review it, just send it to me a week, 4 days before the last day of the month. I'll review it, get you the feedback, and send you any comments or suggestions I have. If you have problems on the homework or questions on homework, let me know. I'm here to help you. And thank you. You guys are all doing good, and hopefully you're having a great week, and hopefully the school's going good and the semester's going good. Let me know.